Hey, it's Dr. J. I'm back. Part 2 of decimal operations. Really only have two main objectives today, and that's to talk about the geometry and word problems. Now, I realized after I posted part 1 that there was a little confusion towards the end with the multiplying and dividing by 10 and powers of 10. So before I jump right into the geometry and the word problems, let me just quickly summarize sort of the main points of those sections. And that way, if I left you in part 1 going, what? Which way do I move the decimal, left or right? Because you probably saw me screw up at least once on that. And it's really about thinking about the big picture. So first, let's summarize of the technique for multiplying or dividing by powers of 10 or powers of 1/10. And so the way that I kind of straighten it out in my own head so that I don't make silly mistakes is to actually stop and think about what you're actually doing before deciding about whether to move left or whether to move right. So really quickly, let me just kind of summarize what's going on. If my camera will behave. There we go. Oh, there we go. So here's a summary. All right, let's start with multiplication. And let's just take a really simple problem and see if we can use that to sort of straighten out what we're doing. So just pick a number, I don't know, 7.23. And I'm going to use the same number for all of these so that it hopefully will clarify what's going on. And it really doesn't matter what number we start with. It's all about the tens. Call this the rule of tens. Okay? So let's multiply. All right, we multiply by 10. You move the decimal one place to the right. That's the one that I would memorize. Multiply right. You're going to move the decimal to the right. And so now I can do various versions of this. Same number, this time 100. Well, move it to the right 2 places. Becomes 723. Technically, it's 0.0, but I would accept just 723. Multiply by 1,000. Move it 3 places to the right. Which it's actually kind of cool if you put that 0, because then when you get to, something that has more places than you have digits, then that 0 then becomes important. 7,230. 7,230. And again, technically it's 0.0. And just to make it complete here, let's do 7.23 times 10,000. That's probably the biggest number I would put on the assignments. That would be 72,300. And again, 0.0. And then typically, if it's a whole number, we typically omit the decimal point and we just enter in the whole number. If there still is a decimal value that's not 0, then you obviously have to put it. So that's multiplying by tens, right? Powers of 10, large powers. So we're moving the decimal to the right. And now you can compare this with multiplying by small powers of 10. A small power of 10 is what I'm calling a small power. It's technically called a negative power, but I don't want to go into that today because I'm not doing any negative numbers in this lesson. But when you come back for the next class in the sequence, you'll learn that 0.1 is actually 10 to the negative 1 power, and that's what I mean by a small power of 10. So this is technically still a power of 10, and so you're going to move it the other way. So memorize, large powers go right, small powers go left. So we would move this decimal to the left one place, and you'd get 7.723. Or 723 thousandths. And I can do all the various powers of 10 that are very small. 7.23 times 1/100th. 1/100th. So that would be 0.0723. So in this one, you're going to move left. Over here, you're going to move right. Now, pay no mind to the fact that I wrote this one on the left and I wrote that one on the right. And I'm talking about which way you're moving the decimal in the digit that is not a power of 10. So 7.23 is definitely not a power of 10. Here, you're going to go 723 times 1/1000th. So you're going to move it to the left, adding another 0. And you get 0.00723. And just to make it look complete, let's do one more. 7.23 times 1/10,000th. Well, it's just going to continue moving one more digit to the left, one more place to the left. And there you go. 0.000723. So this is what I call buy one, get one free. You memorize this one, right? Multiplying by 10, one place to the right. Multiply by 100, two places to the right, so on and so forth. Memorize that. Then moving left is simply the opposite, right? So if you memorize right, you get left for free. Now watch how this works. When I go to the dividing, everything reverses. So reverse the direction now. If I am dividing by 10, I would move left. Yeah? The idea is more of an understanding the concept of powers of 10 and multiplying and dividing being reciprocals of each other. And so the reciprocal changes the direction in which the decimal is going. So if I were to change this into divided by 10, then I would change right into left, and I would change left into right. But it's the same basic concept, just reversing all of the directions. This is going to really come in handy when we get into the next couple sections, where I'll just be doing this as if it were just common sense. So I'm changing all of my multiplications into divisions. So divided by 10, instead of moving left, I'm reversing it, and now I'm moving right. Excuse me, instead of moving right, I'm reversing it and moving left. So now this is going to go and become like this. Yeah? 0.723. In fact, all of these results from the last one that I did are going to be exactly reversed. So these are going to move over here. So this one's going to be 0.0723. This is going to be 0.00723. And this is going to become, I don't know if you can see that one, 7.23 divided by 10,000. That's going to be the same as this one, because dividing by 10,000 is equivalent to multiplying by a 10,000th. And so that will be 0.000723. And so now you can see that the rule for division and the rule for multiplication are simply reversed of each other. Buy one, get one free by reversing them. Similarly, over here, If I change all of these to divisions, by the way, there's another way to write division. I could just write it like this. It means the same thing as the old school quotient symbol. You just write it as a fraction. So I'm going to write all of these as fractions. So this one will be 0.01, this one will be 0.001, this one will be 0.0001. And so now I'm going to take all of these decimals here, 7.23, and I'm going to move all of the decimals to the right. So that will become 72.3. This one will become 723. This one will become 7,230. And finally, this one will be 72,300. All right. So, got it? It's okay if it's still a little sketchy as I move through the rest of Chapter 5. Anytime that I come across a multiple, a power of 10, 10, 100,000, 10,000, or a decimal power of 10, 0.1, 0.001, I will employ this trick whenever I possibly can. Okay? That saves me from having to go like this and trying to type it all out on here. It's much quicker just to move the decimal. All right? But I will keep this handy just in case we need it. All right, that's kind of where I wanted to end part 1. So you can just kind of toss that in with the decimal problems that I did in part 1. Now we're going to move on and do some geometry. So let me just officially start this lesson now. Example 1, we're going to talk about perimeter and area. Let's start off with something really simple that we did before. Formulas that you hopefully already know. Rectangles. So we have a rectangle. Let's say this side is 24.16. And this side is 28.018. Let's do perimeter first. Perimeter means outside measure. So you have 24.16 on this side. That's typically called W. And we have 28.018. That's typically called L. You also have another W over here. Same W. And then you have another L down here, which is also the same as L up there. All right, that's what makes it a rectangle. You got to forgive me, my camera is a little bit at an angle, so it might not look all that great, but it's a rectangle, okay? So the formula for perimeter is W plus W. I like to put my W's together. And then L plus L. Or it's quickly memorized as 2 W's plus 2 L's. So we're going to go 2 times W, that's 24.16, plus 2 times L, which is 28.018. Why don't I just go ahead and do this on Scratch or up here. Scratch work. Scratch. It's an H, right? Scratch. There we go. So here's my Scratch work for this, and then I can just put the result down here. So we got 2 times 24.16. That's going to be 6 times 2 is 12. Carry the 1. 2 times 1 plus 1 is 3. 2 times 4 is 8, and 2 times 2 is 4. So 48, 32. There are 2 decimal places, two digits past the decimal. So we're going to move the decimal over 2 places. And so that becomes 48.32. If you're really good at mental math, or if you're skipping ahead and using the calculator, you will get that value very quickly. Okay. For the 28.08, I got 28.018 times 2. So 2 times 8, 16. Carry the 1. 2 times 1 is 2, plus 1 is 3. 2 times 0 is 0. 2 times 8 is 16. Carry the 1. 2 times 2 is 4, plus 1 is 5. And I already moved the decimal 3 places. So you got 1, 2, 3 places. So 1, 2, 3. And so now the decimal is here, 56.036. And then remember, when you're adding these, I'm just going to go ahead and put the answer here. I have to line them up. 48.32 plus 56.036. And that will give me my result here. And I'm going to put a placeholder above the 6 to make sure I stay on target. I'm going to keep these decimals lined up. Okay, add them up. 6. 5, 3, bring the decimal down. 8 and 6 is 14. Carry the 1. 1, 4, that's a 1. 1, 4, and 5 is 10. And so the perimeter P is equal to 104.356 units. Just generically units. It could be inches, it could be feet, it could be meters. It just depends on what scale we're using to calculate the perimeter. If there is no scale given, then it's just generically units. So there you have perimeter. Next we have area. Area is typically capital A or just A. Area is actually a much easier formula. It's just L times W, length times width. That's your area. You don't need duplicate copies when you're doing area. You just need one W and one L, and then you multiply them together. So, and it doesn't matter what order you put them in, but I'm going to go ahead and follow the order that I have. 28.018 times 24.16. Again, let's do a little scratch. 28.018, 24.16. Now I need to be careful when multiplying because there's 5 decimal places. 1, 2, 3, 4, 5. So I'll have to make sure I clean that up when I'm done. So what do we got? 6 times 8 is 48. Carry the 4. 6 times 1 is 6 plus 4 is 10. Carry the 1. 6 times 0 is 0 plus 1 is 1. Don't bring the decimals down when you're multiplying. Don't do that. Just do it all without decimals, and then when you're done, count and figure out where the decimal goes when you're done. It turns out if you try to put it down now, it's just going to screw it all up. Where am I at? I'm right here. 1 times 8 is 8. No, sorry, not 1 times 8. I'm still on the 6. Ooh, this is going to take a while. Maybe I should just use the calculator. 6 times 8 is 48 again. Carry the 4. 6 times 2 is 12 plus 4 is 16. Put a placeholder. Okay. 1. 1 is a pretty easy trick. When you multiply by 1, you just copy the number. So 1 times 8, 1 times 1, 1 times 0, 1 times 8 again, and then 1 times 2. Now put 2 placeholders. So we're up to 4 now. 4 times 8, 32. I'm running out of space. Carry the 3. 4 times 1 is 4, plus 3 is 7. 4 times 0. 4 times 8 is 32. Carry the 3. 4 times 2 is 8, plus 3 is 11. Finally, 3 placeholders. There's that triangle I was talking about in the part 1 of this lecture, that lower triangle there. You got to be neat and careful with your numbers. 2 times 8 is 16. Carry the 1. 2 times 1 is 2, plus 1 is 3. 2 times 0 is 0. 2 times 8 is 16, carry the 1, and 2 times 2 is 4, plus 1 is 5. Add these up. 8, 8, 4, what's that, 21, yeah. 8, 7, and 6, 21, carry the 2. 2, 6, 8, and 3, that's 19, yeah. 2 and 6 is 8, 8, 16, 3, 19, carry the 1. 1, 1, 2, and 2, that's 6. 1 plus 1 plus 2 plus 2. And then the rest of these are pretty simple. 1 and 6 is 7, and 1 and 5 is 6. Now you want to count your decimals. 1, 2, 3, 4, 5 places. So start over here and move 1, 2, 3, 4, 5 places. This was my scratch work. My answer is 676.91488. If necessary, I want you to round to the nearest thousandth. That's 3 decimal places. Thousandth. So we're going to round to the nearest thousandth. So our dictator is 8. Yeah, that is greater than 5. 8 is greater than 5, so we're going to add 1 to the 4. And my area is going to be 676.915 square units. 676.915 square units. And I'm not going to make a big deal about it today because I just want you to get the right number. So all that really matters today is the numeric portion. But I will start, emphasizing this more and more as we get through Chapter 5, and especially when we get into Chapters 6 and 7. And if you're looking for the light at the end of the tunnel, it's Chapter 7 will be at the end. Whenever we're talking about area is the inside. It's measured in square units because it's kind of like, imagine a bunch of little tiles. I'm not really going to draw them all, but imagine tiles inside. Those are what we call square units. Little squares. So it's like, imagine filling up this rectangle with 676.915. In real life, if this were your kitchen or your bathroom or something, you'd probably just do 677 because 0.915 is almost a whole square unit. But you might have to use a tile cutter or something to make that one fit. So it's not going to be exactly 677. It's going to be 676.915. Okay. So that is area and perimeter of a rectangle with decimals. Let's do a non-rectangular shape. So a shape that's made out of rectangles, but it itself is not actually a rectangle. Call this a polyhedra, an irregular polyhedra. something like that. It doesn't always have to have this shape, but this is a very familiar shape that we've seen before. So 4.7, let's measure this one with meters. 11.8 meters, 3.2 meters, and 12.4 meters. So M is meters. You can actually ignore this until you're done. It's just noting that we're actually calculating this with a real life unit, a meter, which is a little bit more than 3 feet. All right, so let's go ahead and do area first this time, just for a little bit of variety. So we got area here. We got 2 different rectangles. So this is called dissection. In math, we say dissection. In science, they say dissection. It means exactly the same thing. It means to cut it into 2 pieces, yeah, or more than 1 piece. All right, so you have a couple choices on how you cut it. You can cut it this way. Yeah, you do need to make 2 rectangles out of it. Okay, and you can do that in a variety of ways. This is one way to do it, or if you prefer, you can cut it this way. All right. You cannot cut it diagonally because then you won't have a rectangle, and you won't be able to use the neat formula that we have. Okay. So it really doesn't matter. It's your choice how you want to do the cut. It's only one cut, the cut. I guess I'll just go with this one, and I already have it there. Okay. So you've got rectangle number 1, R1, and you've got rectangle number 2. All right, R1. All right, so R1 looks like this. It doesn't have to be an exact diagram. I know that this side is 3.2. Yeah, that's this top piece up here. And I know that this side is not really 12.4 anymore because I have cut off 4.7 of it. So this side is 12.4 minus 4.7 because of the cut. So R1, the rectangle here, I don't even need to write R1 anymore. That's just so that you know that I'm talking about this piece here. You're not actually going to use that in the formula here. So let's go ahead and subtract that. We'll borrow from the 12. 14 minus 7 is 7. And then 11 minus 4 is also 7. Yep. So the area, we'll call this area 1, or A1. It's the area of rectangle number 1. That will be 3.2. That's the length, or that's the width, and then the length is 7.7. And here's what I mean about, saving time. Okay, this is an acceptable use of the calculator. And the main thing is because what I'm really testing you on here is not the math anymore. I'm testing you on the geometric thinking. And so I'm going to go ahead and allow a calculator on this one. 7.7 times 3.2. It also makes my lecture a little shorter. 24.64. That's your area 1. And that's going to be square meters, also known as m to the 2nd power. All right, check, that one's done. Notice you don't actually use the letter R in the formula. The letter R is just to tell me that I've dissected it into 2 parts. Okay. Now the cool thing about the dissection process is once you've dissected one of them, the other one is done already. This is R2 right here. Look. That's my R2. So I'm done. area 2, which is the area inside of R2. Some people just label this A2. Don't even use the letter R. Why introduce a letter that's not necessary? Is 11.8 times 4.7. That's going to be my A2. The little subscript 2 just means it's the second piece. It doesn't actually do any math. It doesn't divide or multiply by 2. It's an indicator of who you're talking about. So 11.8 times 4.7. Isn't that nice? Look how quick that is. 55.46 m squared. All right, and now we're going to add these guys together. We'll call this total area, or total A. We're just going to add these up. So 55.46 plus 24.64. And add them up. Here, I already have my calculator out, so let's go ahead and do it. Plus 24.64. And you get 80.10, or just 80.1 square meters. Okay, so that's your answer. Let's go ahead and just write that up here. Area is 80.1. Again, I can omit this last 0, and I'm going to put m squared, because that's area. Perimeter's a little tougher, all right? With perimeter, you don't so much do the dissection. You just have to fill in the missing sides. Remember, perimeter is the outer measure, right? Perimeter. Now, I should point out over here, we already know 7.7 was the length of this side here, these two sides. So I might as well just copy, before I erase that, 7.7 m, 7.7 meters. Just copy this. All right. So the only side that I don't know is this little segment here. It's 11.8. I'm going to need to find this side by looking here, 11.8, and looking up here, 3.2. So the missing side is equal to 11.8 minus 3.2. I don't need a calculator for that. That's going to be 8.6 meters. So to find the perimeter, just add all the sides. All right. There is no, for this type of shape, you don't use a fancy formula. You just use a little bit of arithmetic, and you're going to add up all the sides. So you know this side is now 8.6. Right. And you can ignore the meters right now, but we'll pick them back up when we're done. So add up all the sides. It doesn't really matter where you start. Just don't double count anybody. I'm going to put a little check mark here so that I know when I've gone around one time. 3.2 plus 12.4 plus 11.8 plus 4.7. I mean, technically, those are all plus, so I'm just going to put a big plus sign. 4.7, and then now 8.6. This is the sum. And then 7.7 is my last, call those addends, or just terms in general. And when I get to 7.7, okay, I'm stopping. I'm not going to double count 3.2. Right? It's easy to go around more than once and get too big of a perimeter. All right, let's just add these all up. If you think it's faster to break out the calculator, you can. Let's see how fast I can do it by hand. 2 and 4, so 6 and 8, 14, 7, 21, 6, 27, 7, 34, carry the 3. 3 and 3 is 6, 2 is 8, 9, and 4 is 13, 8, 21, 7, 28, carry the 2. 2, 1, and 2, that's 4, 48.4. Now you got to go back and pick up your meters. These are not square. These are just regular meters. So your perimeter is 48.4 meters because it's measuring the length of all of the sides as if this were, maybe a piece of property, out in the middle of the desert or something, and you have to put a fence around it. That's how much fencing you would need, 48.4 meters. I don't want to make any mistakes today, so I'm going to double check this. 3.2 plus 12.4 plus 11.8 plus 4.7 plus 8.6 plus 7.7, and I get 48.4. Check. So it's a little bit trickier, but it's the same formula, just dissected into smaller pieces so that you can, we call those digestible pieces, You don't have to eat the whole thing at once. You can break it up into little bite-sized pieces. Next, we're going to talk about triangles. I'm going to kind of go through the ropes, or the same concepts that we've seen before, just with more detail here with these decimals. Example 3. Find the area and perimeter of the triangle. And I already know we're probably going to have some funny numbers here, so it didn't really matter in the last example, but for this one, let's go ahead and round to the nearest hundredth. Just kind of planning in advance that these decimals are going to get out of control. Okay. So now I want to point something out. This is called the base. This is called the height. And these guys are called legs. Yeah. You think of it like the legs of a, I don't know, something standing up, like with a tilted legs under, like a stool or something. Angled legs like this. Technically, the base is technically leg 3. Yeah. But most people don't memorize the formula, leg 1 times leg 2. We don't really memorize it that way. So the area is 1/2 base times height. Yeah, or 1/2 times the base times the height. And the perimeter is leg 1 plus leg 2 plus leg 3, which is also the base. And there's another course beyond this course called trigonometry where we study triangles in complete detail, and we'll give these letters like A, B, and C and things like that. So that'd be A plus B plus C. For now, I'm really more conceptual than I am formulaic right now, so I just want you to understand perimeter means adding up, and area means multiplying. If you get anything out of this lesson, I hope that that's it. And maybe a little bit of experience with how to do decimals precisely. Okay, and since we are doing decimals, you can actually do 0.5 instead of 1/2. 1/2 and 0.5 are the same thing. So we have 1/2, that's your 1/2. I'm doing area first. The base is 6.78, and the height is 4.2. And again, because the objective here is geometry, I don't want to spend 10 more minutes trying to do that all by hand. And so here's an acceptable use of the calculator. 0.5 times 6.78 times 4.2. Oops. Oh, I hit the wrong button. Try it again. 0.5 times 6.78 times 4.2. And so the area is 14.238 rounded. You're going to round up by throwing out the 8 and adding 1, so 14.24 square. Now, I didn't tell you whether these are feet or inches or meters, so I'll just say square units. That's your area. Okay. Perimeter now. Just add up all the sides. 5.19 plus 4.95. Remember, adding, you can do it in any order you like. Plus 6.78. 5.19 plus 4.95 plus 6.78. This one's already rounded, so you can just say 16.92. Rounding is not always necessary. And so this is the measurement of the outside, like a fence, so you would just say units. 16.92 units. One concern that I have when I use terminology like square units, sometimes that kind of contaminates the mind temporarily, mental paralysis, and you might accidentally try to actually square your answer. Please don't do that. Square unit has nothing to do with actually squaring the answer. It simply means that your answer is given in the form of a square unit. So it's almost sometimes we just omit that to cause less confusion, but I know that we're eventually going to cover this in detail, so I'm going to start that process now. Well, there's only one more formula, or one more shape, 2 more formulas that you're going to need to know. And then you can basically rest geometrically for the rest of the semester with the 3 different shapes: rectangles, which also includes squares, rectangles and other types of rectangular shapes, triangles or any type of triangular shape, and then finally circles. And that completes at least our objective geometrically. So next, circles. So a little bit of history. It's actually very ancient history, so I will not be giving dates. I'll just say a long, long time ago. On Earth. Yeah. Come on, come back to me. Is that my glass? Oh, good, we're back. A long time ago on Earth, humans noticed something neat about circles. And when I say humans, I mean it happened all over the world. In China, in ancient Egypt, Mesopotamia, down in South America, Central America, maybe even North America, although we don't have any written evidence of that in North America. But humans did notice something interesting all around the world, probably 10,000 years ago, that there was something very interesting about a circle. And that is, no matter what size the circle is, and it really didn't matter how big the circle was. You could have a big circle, a medium circle, a small circle. If you measure the distance across the center, it's called the diameter. The diameter gets larger, right, as the circles get larger. So here's another diameter. It always has to go through the center. Di means two. Meter means measure. So it's two-sided measure. So you're measuring both sides of away from the center. So these are diameter. So we'll call this one D1. I choose a lowercase d, actually. D1. I have another diameter here. D2. And I have another diameter here. D3. Okay. And again, the subscripts don't have any real mathematical meaning. It just means diameter 1, diameter 2, diameter 3. I'm just trying to emphasize that they are not all the same. They are different diameters. Okay. The outside measurement, called the perimeter of a circle, has a special name. It's called circumference. Circum means to go around in a circle. So circumference means to measure the distance around the outside of the circle. And something very interesting happened. What's really more interesting, I think, about it is that it didn't matter where you lived. It didn't matter what type of language you spoke. It didn't matter what symbols you used. In fact, 10,000 years ago, they probably, more than likely, did not have these symbols. So they're measuring with different number systems. In particular, in South America, the number system was not even a decimal system like we have now. It was a much more complicated base 60 system that was much more complicated. And the same thing occurred in other parts of the world as well, like Egypt and Mesopotamia and such. So what I think is cool about this is when you want to find the circumference, that's called C, something neat happened. Yeah, the diameter would always be related to the circumference in such a way that if you took the circumference and you divided it by the diameter, and it didn't matter which diameter you used, so I'll say C1 for the small circle, C2 for the medium circle, and C3 for the larger circle. It didn't matter which size circle you used, they were always equal. When you divide the circumference divided by the diameter, you always got a number that was very, very close to 3. 0.14 in all of these cases. So if you took, the the distance around this circle, that's circumference, and then you divided it by the diameter, you got 3.14 every time. Yeah? And then if you took a larger circle and you took the circumference and divided it by the diameter for this circle, you still got 3.14. And it didn't matter what size circle you used. And so this number is called pi. Spelled P-I. Yeah. The symbol for pi is the Greek letter P. It's also the Russian letter P and probably a few other languages, in which I didn't look them all up, but those are the two that I know offhand, is Russian and Greek. The symbol for pi is approximately, it's not exactly, it's approximately 3.14159, etc., etc., etc. It is a never-ending, non-repeating decimal. Most people just memorize 3.14. But to be more precise, some of these problems that we are going to do are going to require a little bit more preciseness than just 3.14. But I mean, when you're just walking around in daily life, you know, and what's pi, 3.14, that's the one that most people remember. But I'm going to use 3.14159 because it just makes the calculations come out a lot more accurate. Okay. So that's how we're going to find the circumference of a circle. We'll talk about area in a minute. Let's just do circumference. So I'll give you a circle. Hopefully you can see it. Man, I'm having a tough day today with the camera. I spent half my time trying to keep the camera still. So let's suppose the circumference is 8 units. So I'm just using generic units today, or for this example. Oh, I just made it worse. Come on, come back to me. There we go. So find the circumference. So 8 is the diameter. Okay. And I know that the circumference divided by 8 is approximately 3.14159. Right? So C is the unknown value. D is a known value. So we multiply both sides by 8, and that will tell us the circumference. So 3.14159 times 8 gives us 25.13272. Let's round to the nearest hundredth. Circumference is 25.13 units. 25.13 units. And this gives us a very nice formula. C is pi times d. C is pi d, or pi times d. You actually don't need to use the dot. When you put two things next to each other in math, that means that we're going to multiply them. I'm going to put the dot just to make it extra clear, but that is not a decimal point. Right, that's a multiplication dot. Okay. So there's your new formula. Circumference is pi times d. Example 5. Find the circumference. And I know my circle's not perfect, but just bear with me there, right? The camera angle's a little weird, and I didn't draw perfectly. So find the circumference. C is pi times d, but we don't know d. This is not diameter. It is radius. Radius, we use the letter R for radius. It comes from ray. Yeah, you think of it like a ray of sunlight. Now there's the sun, and here's the earth, and the sunlight is going from the sun to the earth, and it's a ray of light, so it's a radius. It's radiating out of the center. Kind of like spokes on a wheel. Yeah. So all of these spokes have the same magnitude. They're all 7 units. And I guess we'll round to the nearest tenth. Try to do lots of different rounding so you can see all the different ways that I might ask it. So before we do this formula, we first need to find what d is. Now you could memorize a formula for d. It's 2 times r. And that's technically the formula. But you don't really need the formula, right? It's common sense. If this side is 7, then this side is also 7. It's a circle, so the 2 rays are the same. Yeah. And so the total diameter is 14. Now we don't have to round right now. We're going to round when we're done. So now we can come up to our formula here, and now we can plug in pi times 14, now that we know the diameter is 14. So 3.14159 times 14. 3.14159 times 14 gives you 43.98226. This time I'm rounding to the nearest tenth. So the dictator is 8. So the circumference is, I'm putting my answer over here, 43 point, oh no, I hate when that happens, 98. The 8 rounds the 9 to a 10. The 10 rounds the 3 to a 4. So rounded to the nearest tenth, the circumference is 44.0 units. Remember, I talked about this in the first part of 5.1. Whenever you're rounding and you have a 9, you have to bump the 9 up to a 10. I was supposed to say 10 right there, but you can't really put a 10, so then the 1 goes onto the 3 and gives you 44.0 units. Normally, I would omit the 0, normally, but since it says 10th, I want to see the 10th. The 10th is 0.0. That's round to the nearest 10th. So now you have two formulas. You have C equals pi times D, or you can get rid of the D and write it as 2R using this formula, and this is typically rewritten or reordered. 2 goes first, then the pi, and then the R. It's kind of like alphabetical order, right? Numbers go first. That's like the top of the list. Then pi, which is like P, and then R. R comes after P in the alphabet, so it's 2 pi R. On the test or the quiz, I don't care which of these formulas you use. You can use pi D if you find that one easier. You can use 2 pi R if you find that one easier. All right, what's neat about the 2 pi R formula is watch how quick this is now, if you know it. This formula is much faster if you know that the radius is 9. So the circumference is 2 pi 9. Now technically that's times there. And this is also times. And I'm going to approximate that with my calculator. So 2 times 3.14159. That's 2 pi, which is like 6 point something, 6.28318. And then finally times 9. And just that quickly, you have the circumference 56.54862. Rounded to the nearest tenth, 56.5 units. That's the sort of streamlined, efficient way of just reading the question, using your technology to your advantage, and coming up with the answer without a whole lot of smoke and mirrors. Okay. It'll be less confusing. It's supposed to be. But it does require that you know the formula. If you don't remember this version, then you can always go back to the pi d one, which I hope you'll never forget. I mean, that's the one your ancestors knew thousands of years ago. If they knew it thousands of years ago, you certainly can know it today. And pass it on. Okay, next we're going to talk about area of a circle. Area is a little bit more complicated because area involves square units, right? So we want to know how much space is inside of the circle. Imagine having a house, you know, where the living room was a giant circle, like a dome home or something. Why don't we just use the same circle? I'll call this 9 again. I know I drew it a little bit bigger, but I don't have to make the numbers complicated. I traditionally don't make the numbers complicated. I'll give you very simple numbers, and then I want you to know how to find the area. So I'm just going to go ahead and give you the formula for the area. It's pi r squared. Not times 2, but squared. Now, there is a similar, system of diagrams that I could show you that tells you how much space is inside of the circle. The explanation of this formula is a little bit beyond the scope of this class. So this is more of a faith-based formula here. You just have to believe me that this is the formula, unless you want to sit through another hour-long lesson on how this formula came about. circumference one you can tell in a couple minutes, but this one takes a little long. So that's pi times 9 squared. And if you really want to be careful, put a dot there so that you know you're multiplying. Now 9 squared, be careful, it's not the same as radius and diameter. This is the square of the radius, which is 81. And now you can use your calculator. I think this one on the homework says round to the nearest hundredth. I forgot to write that part down. I typically don't read that until I'm done. So I read the question, I kind of blow over that or ignore that, I do the problem, and then I go back and I read it one more time, and I go, oh, okay, round to the nearest hundredth. So this time the dictator is the 8, right? You go 1 digit past whatever it's asking for. And so that 8 is going to be bigger than 5. Anything bigger than 5, you would add 1 to the next digit. And so that 6 is going to become a 7. And this is square units. 254.47 square units. My battery's about to die. Don't die on me, I'm almost done. I don't know if we're going to get to the word problems today. This is taking me longer than I expected, and I'm using the calculator, so. All right, so there's your area. A couple more circle examples. Example 8. Find the area. So when I draw a line across the circle, I either go all the way across or I go halfway across. If I go halfway across, it's radius. If I go all the way across, it's diameter. Okay. Now again, there is a formula for converting between diameter and radius. But I feel like you've got so many formulas, the last thing you need right now is an extra formula to memorize. So don't even bother, just use common sense, right? And I'll always give you easy numbers, so it will be basic common sense. If the diameter is 24, then the radius is half of that, which is 12. Yeah, so R is 12. Half of the diameter is the radius. So the circumference is pi r squared. There's your R. Pi times 12 squared. Pi times 144. Again, be careful with squaring. All right, my calculator actually doesn't have a square button on it. I don't have a scientific calculator nearby, so I'm just using this is what I use to pay my bills. So 144 times 3.14159. That's approximately 452.38896 square units. And then you can round this if you need to. Some problems might not even ask for any rounding. If it doesn't ask, then don't do it. All right. I'll take it as long as it's right. Okay, so those are your formulas. You got rectangles, you got triangles, you got circles. So those are basically that's the extent of our geometry knowledge. I am going to do an application of circles. This is what we call a shaded ring. Just like the name implies, it's a ring. It's typically shaded solid. And then I'll give you two measurements. We'll say this one is 8, and this one is 6. It's a little bit hard to see the one that goes to the outside sometimes, unless you're printing in color or something like that. You know, if you're just printing this in black and white, you need to be careful because sometimes this one will, it's hard to tell. Just, again, use a little bit of common sense. The larger one goes to the outside. Yeah, so we call this big R is 8. And the smaller one goes to the inside ring. We typically call that one small r, and that's 6. So the area of a ring is pi times big R squared in parentheses minus little r squared. And I usually just write the pi one time, and then the parentheses will allow me to follow the order of operations, right? Which I'm really fond of. In other words, we do the squares first, then we do what's inside the parentheses, and then we'll multiply it by pi when we're done. So big R is 8, so that's 8 squared. Little r is 6, that's 6 squared. Be very, very careful. It's very common to subtract these first, but that's not the order of operations. It's square them first. So 64 and 36, and then subtract them. So 64 minus 36 is 28. I'm running out of room, so I'm going to put it up here. A is pi times 28. What's inside first? And then I'm going to approximate that with my calculator. 28 times 3.14159. That's 87.9. I'm going to round this one to the 100th, so 96 square units. Okay, so that tells you how many little squares, if they were little pieces of carpet or tile or something, you would need to fill out this entire ring. Oh, word problems. To be continued. I think we've had enough. I'll put all the geometry in one lesson, and then we can move on to something else. I don't know. I'll think about what I want to do about the word problems. But until we meet again, this is Dr. Jordan. I'll see you on the internet.